In this lesson, I'll be leading you through some examples of calculating area, and the examples will go from questions that are quite basic, including explaining what area is all about, up into other questions that involve mixing in some of the topics that we covered earlier in the course. So first of all, let's look at this question here where I'm going to be asking you to calculate the area of a rectangle. Throughout the video, I would like you to pause the video if you can handle the question yourself, or at least if you have an idea of how to answer it. So from what you remember, what is the area of this rectangle? What does that actually mean? Pause the video, answer the question, and then unpause when you're ready. So the area is the amount of space inside an object, a two-dimensional object, an object that can be drawn on a piece of paper, like a rectangle. And when it comes down to area, we measure area by how many squares could actually fit inside. So one way to actually figure out the area here is to count up how many squares are actually inside the shape. 1, 2, 3, 4, 5, 6, 12, 18. There's 24 squares inside, so the area is 24. A quicker way, instead of counting, is to actually count how tall the object is and how long the object is. So this rectangle is 4 spaces by 6 spaces. We can use those numbers by just multiplying them together to get the area. So the area formula, you may know it as length times width. It's also called base times height. And here the base, or the bottom of this rectangle, is 6 spaces long, and the height is 4 spaces tall. So the overall area is 24. In our second example, we're taking a look at a rectangle that is a little bit incomplete. So if we want to figure out the area of this rectangle, we would be using base times height as one way to get the area. And since it's a rectangle, we know we've got right angles here in all the corners. So we do know that this number right here represents the height, but it's unknown to us how tall the triangle is, or how tall the rectangle is. So if we go to use area as base times height, we would do area equals 7 times, and it's a mystery right now of what the height is. So this is where we're digging back to some work that we did earlier in the year. If we have a right angle here, how can that help us figure out how tall this rectangle is? Pause the video and figure it out for yourself, and then unpause when you're ready to continue. So hopefully you thought about using the Pythagorean theorem to figure out what the length of the height would be. Our A would be 7, our B is what we're looking for, and C has to be the longest side of that right triangle. So we're going to use the right triangle here to apply Pythagorean's theorem, a squared plus b squared equals c squared, and plugging in the numbers that we know. The A is 7, the B is what we're looking for, our height, and the C is the longest side of the triangle, which is the hypotenuse. We end up getting 49 plus h squared equals 64. Subtracting away 49 will tell us that h squared is worth 15. So h would be worth radical 15. So finishing our work up here, the answer would be 7 times radical 15. Since the question did not say to round, we would leave our answer just as it is right there. Now you could go ahead and multiply those together. Radical 15 is about 3.87. So typing that into the calculator, 7 times radical 15 would give you an answer that's close to approximately 27 squares. So in this question, the area is half base times height, and the base, it's usually on the bottom, and we can turn this paper upside down if we wanted to and call that the base. If it makes you feel more natural to do that, then go ahead and just twist the paper around, rotate that paper around. But for me, I'm just going to leave it as this and just count this up. 1, 2, 3, 4, 5, 6, 7, 8 spaces across for the base. So to calculate the area, I'm going to do 1/2 of 8 times the height. So I do have to figure out the height. The height is always perpendicular to the base. You can use the word altitude if you want to sound like a professional. So we have to figure out the length of that altitude, or how tall that triangle is from the base to the tip. Altitudes always make right angles to the base. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the length of the height. So it'd be 1/2 of 8 times 10, or 1/2 of 80. So there would be 40 squares inside that shape. And if you wanted to try to start counting them, you could. But you'll notice that some of them are incomplete. Like that's not really a full 7 squares right there. But there's a full 7 there, and 8, 9, 10. But you have all these partial squares here and here that when combined together will make more fuller squares. So some careful counting can get you close to 40, but because of the way that it's drawn, it'd be really quite tricky to capture the idea of what the area is by just counting. So this is 10 spaces for the height. Some students will tell me that it's 11. Some students will tell me that it's 9. A student that says 11 will say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is wrong. You're not counting how many intersections you're hitting. You're counting how much it's moving from space to space. So don't start by counting 1, 2, 3, because that is not 3 spaces long. When you start counting, start at 0, 0, 1, 2, 3, which is good counting. And then for some students that want to tell me that it's only 9, they'll get down over here and say, that's 9, but I won't count this because it's not a full square. No, you're not talking about how many squares you're seeing. You're talking about how many steps you're taking. So it's 10 all the way down. I'm going to squeeze one more little bit out of this question by just erasing it and letting you, or reminding you, that when it comes to the triangle, as long as the base is 8 and the height is 10, the triangle will have exactly the same area. So I could draw in this blue triangle here. This also has a base of 8 and a height of 10. So this will also have the same area, except it's a different type of triangle. This triangle is a right triangle. And there are many triangles I can draw that will have an area of 80. So I could actually, instead of having the vertex there at 0, -4, I could have it slightly moved over here. And this red triangle will have the same area as the blue and the same area as the black. This green one here will also have an area that is 40 because the base is still 8 and the height is a measure of how tall it is from the base to the top of the triangle. So the top of the triangle is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces from the base of the triangle. Remember, the height always has to form a right angle with the base, and sometimes the height appears, or the altitude appears, outside of the triangle. If you're not sure you know what that means, we'll do one more. Okay, the one sitting right next to it is asking you to find the area. And the quickest way to do this is, well, first of all, realize that it's not a right triangle. So neither of these, if we count this as our base, we would not be able to use this as the altitude because it's not forming a right angle to the base. And this certainly is not the altitude of the triangle if this is the base, because this angle here is clearly not a right angle. And with some pretty quick counting, that's 7, that's 15 spaces across. So the base would be 15. Now the height is what I need. And the height or the altitude would have to make a right angle to the base, and you're going to have to count up how tall that is. So it's 5 spaces from here to here. I can see that, and there's another 8 spaces from here to here. So altogether that is 13 spaces for the height. So half of 13 times 15 ends up being 97.5 spaces for the area. 97.5 squares inside. And if you took a look at this and started counting it up, you see that that answer makes sense. I mean, there's practically 100 little squares inside this giant triangle. So for this one here, it's not as easy as the last few, and why not? So that's something to take a look at. Maybe pause the video. How come using 1/2 base times height, how come that would be a difficult thing to do on this question? Pause the video and think about it, and then unpause when you're ready. Maybe you're thinking about it the right way. If you wanted this to be the base, then you would need to figure out the height, and the height would be going on a diagonal to the base. That can be figured out. You could figure out how long this is, but then you're going to have to also figure out how long this is here, and you're going to have to figure out where that altitude would actually hit the base. Now you could call this the base, and then call this the height, but again, you're going to have to actually plan out where exactly does the base and this height here connect? Where do they join so that you could actually maybe use the Pythagorean theorem and work it out that way. So the reason why this question is so hard to solve is because the bases are all going diagonally, which would mean that the heights would all be going diagonally as well. So it would involve some careful counting and planning to figure out, or using a different approach. So sometimes on the toughest questions where you're trying to figure out the area, even though we could use 1/2 base times height, sometimes it's easier to do this method here, is to have this plan where you surround the triangle that you're looking for with a rectangle or square, and then subtract away the pieces that you don't want. So looking at this picture right here, I've got my plan laid out to the right. The area of the rectangle would be base times height, which in this case is 1, 2, 3, 4, 5, times 1, 2, 3, 4, 5, 6, 7. So using base times height, I get 5 times 7, which is 35. So the blue rectangle is worth 35 squares. You could count them actually if you wanted to. There's 35 squares inside. But that's way too much. We want the area inside the black space there. So to do that, we're going to have to trim away the colored triangles that are showing up. So the area of a triangle is 1/2 base times height. For the green triangle, that's 1, 2, 3, 4, 5 for the height, and 1, 2, 3, 4, 5 for the base. So it'd be 1/2 of 5 times 5. 1/2 of 5 times 5 is 12.5. And you can go along that route the same way. The yellow triangle has a base that's 1 and a height that's worth 7. So 1/2 of 7 times 1 is 3.5. And then the red triangle is also 1/2 base times height. The height is 2, the base is 1, 2, 3, 4. So 1/2 of 2 times 4 is 1/2 of 8, which is 4. And then you're just simply dialing that in, you can subtract it in your head if you want to. 35, take away 12.5, take away 3.5, take away 4. Comes out to be 15 spaces. And for the area that we're looking for, the area of the black triangle here. And then, again, by counting, you can see that actually seems to make sense. How many squares are actually inside here? Well, just by quickly counting, I'm already up to 6, 7, 8. I'm up to 8 whole squares, and all these partial squares here must make up a few extra squares to add up to be a total of 15 inside for the area. One more example to walk you through. And this question you can actually solve in more than one way. So let's pause the video and give you a chance to try to do this using any method you'd like. You could use the method from the last example if you'd like. So pause the video and restart it when you're ready. So if you solved it by surrounding and subtracting, your plan could possibly be to start with that blue rectangle or square and take away the 4 little triangles that are appearing there. So if you solved it that way, you're getting an area of 42 inside, 42 squares inside that rectangle or inside that shape. Now another way to solve the question, well, if you haven't thought of another way, maybe pause the video and give that some thought. What's another way to actually figure out the area of this shape, which does not involve surrounding it with a square and subtracting away the triangles that are showing up? You may have thought, well, instead of actually subtracting away triangles, why don't I just take triangle number 1 and triangle number 2 or 4 and put them together to make a square that has 9? That's actually pretty clever. You could take triangle 2 and triangle 3 like puzzle pieces and put them together and get a giant square that's 7 by 7. So that's another way to actually solve it. But there's another way that could be used using coordinate geometry, and that is to realize that the shape that you're looking at is truly a rectangle. It looked like a rectangle, but this guarantees it. Figuring out the slopes. The slope of AB is up 2 over 2, which reduces to 1. The slope of BC is down 7 over 7, which reduces to negative 1. 1 and negative 1 are negative reciprocals. If you remember that, because 1 is 1 over 1, and negative 1 is negative 1 over 1. So if you switch the sign and flip the numbers, you end up getting negative 1 over 1, which would end up being an example of a negative reciprocal. And the same thing could be said about sides CD and AD, that their slopes are 1 and negative 1. So since we've got all these negative reciprocals, it means that we have 4 right angles, so it has to be a rectangle. And since it's a rectangle, we could use area equals base times height to figure out the area of the rectangle without surrounding and subtracting it. But that still gives us another challenge of figuring out the base and figuring out the height of that rectangle. So how do you find the lengths when they're going crooked like this? Well, perhaps you already know, but it's the Pythagorean theorem. The Pythagorean theorem will tell you how long it is from A to D. So remember, you can always take those numbers there and use a speedier version of the Pythagorean theorem to get that it's radical 98. And then from here to here, it's up 3 over 3. So 3 squared plus 3 squared square rooted is radical 18. You just have to plug that into the formula to get radical 98 times radical 18. And it almost seems a little bit magical here that the answer comes out to be exactly 42. The same as the other way that we solved it. The same answer from the other way that we solved it. All right, so for you on this assignment coming up, hopefully the video does help. So we've got some basic examples here, figuring out the area of a square and a triangle. Another triangle for the third picture, and this arrowhead here. Let's see how you figure out how to do that one based on what I've shown you. And then there's 2 more examples to work out, figuring out the area of this triangle, which can be done a couple different ways. And then figuring out the area of this shape here is a little bit of a challenge for you.